Okay, you guys are being recorded now. Okay, cool. Hello. Okay, it's probably time to start. So we're sort of on a clock here. Hopefully the other people are in the other room. So I'm Alice Bean, and thanks for coming. We're celebrating today. So from 11:40 to noon, we're gonna have our KU specific thing. And so everyone on this Zoom, I'm glad you made it. But at noon, you're gonna switch to the other Zoom so that we can join the US celebration. So what I wanna do is talk a bit to tell you why we're here. So what is particle physics? Well, we investigate matter at the smallest scales. So what are we trying to figure out? We're trying to figure out how things work at these scales. So we have our atom, and inside the atom are like protons and neutrons, and even smaller than protons and neutrons are our quarks. So inside of the proton, for instance, are up quarks and down quarks. So quarks are really small particles, and then there's a whole nother set of small particles called the leptons, and they're the electrons. So we know a lot about these, and we know how they interact, but we need to find out a lot more. So in case you're wondering, all of these all these particles, this is a program that was started at University of Kansas called the Quark program. And we had lots of help from people besides particle physicists. Anyway, you can go to quark.org to learn more about it. We got lots of refrigerator magnets and all sorts of stuff so that you can learn more about particle physics. We hope you do that. But so let's look at this particle physics. What we're here today to celebrate is it's the 10th anniversary of discovering the Higgs boson. So here he is. This is the Higgs. You can go buy this at KU's Natural History Museum if you want one of these. So you're going to learn a lot more about this at the US celebration later. So I'm only touching on this very briefly. So the Higgs boson was the last piece of the standard model of particle physics. And it's pretty important because we think it is why particles are imbued with mass. So some theorists postulated it way in the 1960s, and it took us till July 4th, 2012 to actually announce it. So this was the big deal, and this is part of the reason that we're here to celebrate. So if we look at some of the things that have happened, KU postdoc Anna Kropivnitskaya actually made the front page of the Australian because she was at a conference at that point when the announcement happened on July 4th. So this was a big deal, and KU has been a part of it, and I remember lots of things. You can ask me later about it. So what are we doing? Well, we're part of the Compact Muon Solenoid collaboration. So at the Large Hadron Collider, it's underground near Geneva, Switzerland. And here's a cartoon, and it's underground there. And underground there, there's this particle accelerator called the Large Hadron Collider. And that Large Hadron Collider can collide protons, and it can collide other particles. And right now, it's the highest energy particle accelerator in the world. Now, there's several collaborations of scientists that have made giant detectors to try and take pictures of what happens there. And we're part of the collaboration that runs the CMS detector. So if you look at the CMS detector, it's a giant detector, and you can see the size of a person is just that. So it's a 5-story tall, big giant detector. It has lots of different parts. They're really high tech. And the whole idea is to capture all the energy and figure out what happens when protons actually collide in the center of it. So this giant detector we've been making for a while, And at this point, our collaboration involves 54 countries, and that's 241 institutes, including, for instance, the University of Kansas. And presently, there's 5,500 affiliated people. So that includes physics, PhDs, and that also includes some engineers and undergraduate students and graduate students. In our collaboration, people from the US make up 30% of the collaboration. The US is a large part of this giant scientific enterprise. Now, KU joined into the collaboration in 2000. Professor Beringer and I initiated this. And we've been in there ever since. And so you say, wow, 2000, we've been doing this a while. So who at KU does this? We have two major research groups in the department. So there are the particle physicists and the nuclear physicists. Particle physicists, I'm a particle physicist. We study proton-proton interactions and sort of those elementary particles. The nuclear physicists study heavy ion, like lead ions on lead ions, and also forward collisions. And they're trying to figure out about the strong force that holds the proton together. So we want to thank all of our sponsors, including University of Kansas, and we're really heavily supported by the National Science Foundation and the Department of Energy. So these groups then, here's a picture of us at one point in time. I think this was around 2016 or 17. Here's the CMS collaboration, the people just at University of Kansas working on this project. Here we're in front of just down on Jayhawk Boulevard, and also at Fermilab and all other places, and at CERN. So we have people all over. So why are we here today? I'm just giving you a touch of stuff we're doing. We're here to celebrate the 10th anniversary of the discovery of the Higgs boson. So the paper that CMS released in 2012 has now been cited over 18,000 times. It's one of the most cited papers in history. And in this international science program, we all work together. And once you do your service work, you become an author on every single publication. So I have 1,100 publications to my name from this. And the KU CMS group, as I said, joined in 2000. Since that time, we've had over 160 KU researchers alone. That includes 8 faculty members, 22 postdocs, 38 grad students with 16 PhDs, and we keep counting and it keeps going up. We've got about 100 undergraduate researchers who have worked with us. So we also want to directly thank our Department of Physics and Astronomy staff, including we have machinists, we have electrical engineers, we have electronics technicians, and Kristen, who we all couldn't do without, runs everything. So anyway, our staff. And we also want to thank our international programs, like Charlie Bankert's here. We've had study abroad. People go to Switzerland and help us with that. To date, we've had over 23 million in federal funding, and that's included over 15 million from the NSF and over 7.5 million from the DOE. Now, we've actually presented in just conference papers, more than 230 conferences. I just want to make a shout out to all of our PhDs graduated so far. Our first one graduated was Jay Chen with lifetime results on how to look for long-lived particles. And then our latest ones are Christian and Tommaso. So we've had a great group of PhD students and we're looking to have more. So what have we done in the past? Well, we actually helped build the detector. The innermost part of the detector tracks charged particles, and you can see that in the pictures on the top. We actually built some parts of the detector and tested them at University of Kansas. Those, you can see us working in our lab upstairs. People are invited to after some of these festivities, we're happy to give you tours of our labs. So we actually made some of the stuff up there. This is the detector that's in there that we tested some parts. Now, Michael Murray on the nuclear physics side is in the tunnel at CERN with Jessica Snyder, an undergrad, working on the 0-degree calorimeter. Now, we've been a part of a lot of physics. I'm not going to go through it, but we've had more than 230 times just at conferences. This is scientific conferences alone. This has included undergraduates presenting posters. It's included graduate student Andreas at the Division of Particles and Fields. Here's Margaret at this year's APS meeting, American Physical Society meeting. So we've had lots of physics analysis done, and we're still going. So another thing that I want to point out, and part of the reason why we had paired with our study abroad, is KU led a grant from 2008 to 2014. We were the head institute with over five US institutes. And we brought over 50 undergraduate and graduate students to live in Switzerland for at least the summer. This was quite a thing. And we had a lot of fun, learned about Swiss fondue and all kinds of other things, and had a great time. Now, if we look at KU now, we have 32 KU researchers working on CMS. And here you can see a picture from what we refer to as our physics prom, the department banquet this year in the top. And presently we have 6 faculty members, 6 postdoctoral researchers, 3 located at CERN, some on this call, and 12 grad students and 8 undergrad students. So I put pictures of some of the grad students and faculty working on it right now. So what are we doing? We're helping to build parts. Our detector isn't quite done and you leave it alone. We're building new parts. They're new high-tech parts to be installed in 2026 because we're going to be running for a while now. We haven't taken all of our data. And we have undergrads, grads, faculty, postdocs working in Malat Hall to build this. So 2 parts of the detector that we're working on are the inner tracking detector, sort of with my group, and Professor Rogan's group is working on the in-cap timing detector. So there's pictures from both. Then the other thing is, and we're going to hear more about this in the US national meeting, is, okay, so we discovered the Higgs boson 10 years ago. That was the final piece of the standard model. Are we done? Well, no. And you can see, you can't read all this stuff because there's so much to do, okay? One of the things that I'll highlight here is supersymmetric particles. So we think there might be some whole new set of particles, new dimensions, and the KU CMS group is trying to answer some of these questions. So for instance, using techniques developed at KU, well, by KU researchers, the KU CMS group is presently, we're not allowed to totally talk about it yet, completing an analysis looking for dark matter particles, which could be supersymmetric. And we have, this is part of our analysis on it. And then Ricardo here sitting in the CMS control room has been a shift leader, and we are starting to take data. We start July 5th at a new energy, and we're ready for all this new data. So we have a couple of grad students here who are just going to introduce yourself and tell us a little bit about. So where's Margaret and Zach? So Margaret, come for the mic here.
Hi, everyone. I'm Margaret. I think most of you guys know me. I'm a graduate student with the KU CMS group here, and I work on a couple of projects that Professor Bean has described. The first one being the search for supersymmetry, which is really exciting. I got to learn a lot about analysis work, coding, and how we look for new particles. The other project that I'm working on is mechanical testing for the new detector that Professor Bean described. So I've got to work actually with KU Mechanical Engineering, which has been a really fruitful collaboration.
Cool.
That's what I do.
Zach. And so these guys are going to be around. Part of, you should talk to these guys and find out more. Zach.
Hi, my name is Zach. I'm also a grad student here. So in addition to working on the SUSY analysis that Mark just a little bit more about and Professor Bean said a lot about, I also work on this uncap timing detector. So primarily I'm focused on electrical properties of a bump bonding study that we're doing. So the idea basically being we have a new detector in order to try to discover new physics coming. And we want to make sure before we go and just install this thing at CERN that everything actually works. And we have an entire lab upstairs basically dedicated to that. And if anyone's interested after, say, lunch, I'm happy to give a tour of that lab upstairs as well.
Okay, cool. So that was a really brief walkthrough of stuff that's happening at KU. We have just a couple minutes here because then we have to go to the US Zoom. But if people have questions or comments or something, and I want to ask them now before we go to that, let us know. Come on, you guys, go for it. Yeah.
So I'm just wondering about the impact that the pandemic has had in terms of the collaboration, visits to CERN, pushing this research forward and such.
Okay, so Charlie Banker's asked us about the impact of the pandemic. So all of our labs did get shut down here at KU, but we actually had people working solo in the labs. One of the pictures above, you can actually see that in the middle here, you can actually see everybody has okay, so we were all masked and we were doing stuff basically, and the pictures of singles down below are because there was only one person in the lab. So we were testing things in the lab. Now, particle physics, we've been doing video conferencing since before 2000. So this is how we work in our normal world. So the video conferencing part and how we do our meetings, we've had meetings on video conference for a while. So everyone has been working from home. So yeah. Yeah, for some people, they actually got more done because they were sitting at home doing more work. Other questions? Yeah.
What new energy are you going up to soon?
So we started that Higgs analysis. We started at 8 trillion electron volts, and that was where we were working for a while. The latest run on our data that we got done with, that was done in 2018, that we ran through 2018, that energy was 13 TeV, 13 trillion electron volts. The energy that we're starting up at next week, we've been doing calibration and stuff, but the first real run at 13.6 trillion electron volts. So a whole 0.6 more. The whole design of this thing was 14, so we're almost there. It's actually kind of hard to get to 14. The magnets that do this accelerator are really picky. It's really hard. So, but the 13.6 will be slightly new energy. But one of the main things that we're really looking for is we're going to get a higher data rate. Okay, so the amount of data, our rate of taking data is going to be much quicker. That is what is actually stressing some of us out because we need better technology to take this data quicker. Yeah. Oh, okay. Any other questions? Cool. Well, it was actually fun for me because we were trying to find photos. So we're gonna keep running a set of photos that we found as a slideshow. Oh, in the chat, we have people in the chat. What are the people in the chat asking?
Yeah, Graham posted the password for because we have the Zoom link that we'll have to move to, but there's a password as well that he posted. Yeah.
Okay, yeah. Okay, wait. How do I get out of here?
We,
Anyway.
we want to switch this one to the international
The
or the
inter-
CMS.
The
Okay.
US CMS
Do you
one.
know where I can get a link?
Uh,
So I'm gonna disconnect.
Okay, we're leaving the KU one, so show up in the other place. Graham will still be in the KU one for people.
10 people. Thank you. Okay, I'll move.